How are you all? I hope that you all are doing really, really good. Okay. Um. Okay. So this is the very first video on my channel, and my whole purpose is to just make you all aware of what actually system design is and what is the role that it plays in most of the companies out there and in a lot of interviews. As we all know that recently what is happening now that most of the companies system design rounds are very very like mandatory. They will even have like 2 3 rounds of system design interviews. Okay, I myself faced a lot of problems while I was starting and when while I was giving the interviews for the system design. So I just really want to make a step in the learning of how I can make myself better and how I can make you all aware of more about the system design. Okay, so first discuss what is actually a system design. So when I was in college, right, system design, I think that it's not a thing. Okay, it's just that DSA and all other subjects like OOPS, multi-threading, they are the like basic, they are the most important things when I'm talking about the interviews. Eventually they are the most important thing, but system design is also important. System design is something like how the projects in our industry, in the IT industry, are actually designed, how those systems are actually built, what all components are being used. Okay, how module interfaces data, how all those things are correlated, how they are coupled. So if I'll read the definition, right, so system design is the process of defining the architecture, components, modules, interfaces and data for a system to satisfy specified requirements. Only for a specific requirements. If suppose I'll take an example, if suppose I have to build a book my show. Okay, so for book my show, what all components needs to be there, what all modules needs to be there, what all architectures needs to be there, how can we build a very good architecture so that it can scale as in that how it can handle a various and large number of users. Okay, let's continue. It's a blueprint for building scalable, reliable, and efficient systems. In the context of software development, system design involves making high level architectural decisions as well as low level technical details. So, uh, system design generally constitute of two maybe aspects that I can say. So first is high level, that is your HLD, and second is low level, that is your LLD. Okay, so in most of the interviews, I think you might have rounds to the HLD or LLD. LLD is how you are defining the classes, objects, how those classes are related, how the modules are going to define that is particularly low level design, how algorithm needs to be written. And high level design is how your component needs to be designed, what load balancer will you use, and what all techniques will you use, what all type of DBs you'll use. All those things will be covered in the high level architecture. I hope that you all got understanding of what all system design is. Now, system design principles. When someone will tell you or maybe ask you what is system design principle, you all might just wonder solid principles, all those things. I even think the same thing. But when I was studying, when I was learning system design, I got to know that there are a lot more principles apart from the solid principles. Okay, so first is the dry principle, that is don't repeat yourself. So whenever we are writing a code, we should always avoid code duplication. Each piece of the logic should exist only once. Second is kiss, that is keep it simple. Okay, let it behave stupid. Okay, We all know that simplicity wins. Avoid over engineering. Third is Yagni. That is, you aren't gonna need it. Do not define the features until it is necessary. Do not define the unwanted features. It will eventually increase the length of the code. Solid principles, the basics of O principles for maintainable code. That will define maybe in the next video. That we'll discuss in the next video. The other principles are, apart from those, is separation of concern. Separation of concern as in that divide system responsibility into distinct parts. Okay, I'm just taking the same example as in Book My Show. Okay, for Book My Show there should be system responsibility. There should be something for showing the movies, events, or something. There should be something else for maintaining the booking, all those stuff. Okay, so divide system responsibilities into distinct parts. The next one is high cohesion and low coupling. High cohesion as in that related functionality should stay together. Low coupling as in modules should be depend as little as possible on each other. Next is design for failures. Accept and handle failures gracefully. Okay. Always try to have your code written for handling the failures, for timeouts, for retries, fallbacks. The last one is favor composition over inheritance. We should always use object composition for flexibility rather than deep classic hierarchies. Object composition, as in that you should always define your objects with you should always define your complex objects with some small or independent objects out there rather than using inheritance. That's it for today. I hope I'll be able to help you out in understanding the principles of the system design apart from the solid principles. Yeah. Bye bye. See you in the next video.